Hello everyone, in this video I will show you how we can solve the example using RSA algorithm, and this question is asked in Mumbai University question paper in May 2022 as well as in May 2023. So in this example, what is given? Elaborate the steps of key generation using RSA algorithm. This is your theory question and that will be asked for 2 marks, and total out of this 10 marks question, 2 marks will be allocated for your theory and 8 marks will be given to your example. So in RSA system, the public key EN of the user A is defined as 787. So E will be 7 and value of N will be 187. And we have to calculate the value of our phi of N, value of our private key, that is D, and after that we will find the value of our ciphertext. So what is the value of ciphertext for M is equal to 10 using the public key? So value of our M is equal to 10, that is the value of plain text is equal to 10. So first of all, we will solve this 2 marks question, that is elaborate the steps of key generation using RSA algorithm. So the step 1 is, first of all, we have to choose the value of P and Q. These are the prime numbers. So we have to choose the value of this prime number, that is P and Q. Then we will calculate the value of N is equal to P into Q. The third step is, we have to find the value of our phi of N is equal to P minus 1 into Q minus 1. The fourth step is, we have to select the value of our public key, that is value of our E, and this E should be between 1 less than E less than phi of N, and E should not be the factor of phi of. Then also we can check GCD of E and phi of N is equal to 1. Now the fifth step is, we have to find the value of our private key. And your private key, that is D, is equal to, how we can calculate? D into E mod of phi of N is equal to 1. Then there are process for encryption and decryption. These are the two processes are there. First we will find our ciphertext based on the plain text message is given. So ciphertext is equal to plain text raised to E mod of N. And in the process of decryption, we will take our plain text, we will find our plain text based on our ciphertext. So value of our ciphertext raised to D mod of N. So these are the steps are given in the RSA algorithm, and this will be asked for 2 marks. Now we will solve the example using this RSA algorithm, and whatever the steps we have elaborated here, based on that we will solve our example. So the example is, the public key E and N is given. So that is our public key E and N, and which is given here of 7 and 187. So value of our E is equal to 7, value of our N is equal to 187. And in the given example, we have to find the value of our phi of N, value of our D, that is our private key, and value of our ciphertext. And here the value of our plain text, that is message, is equal to given, that is 10. Now what is the first step? We have to choose the value of our prime number, that is P and Q. In the given example, value of N is given. Based on that, we will find our value of our P and Q. So the first step is, N is equal to 187, that is given, and we will choose prime numbers that is P and Q. So first of all, we will make the factors of this 187 and it should be two prime numbers. So we will take 11 into 17. Then we will get value of our P and Q. So our P will be 11 and our Q will be 7. So P and Q, it should be factor of 187. That is our value of our n. So 11 and 17, these two values are factor of our 187. Now in the second step, what we are finding? That is the value of our phi of n. So phi of n is nothing but P minus 1 into Q minus 1. So P minus 1, that we are putting here, value of P is equal to 11 minus 1 into 17 minus 1. And we will get the value that is 10 into 16 is equal to 160. That is the value of our phi of n. So our phi of n is equal to 160. So now the third step is we have to find the value of our E. So E is already given, that is value of E is equal to 7. This is our public key. So if we are writing all the statements again in our solved example, we have to show that these three rules will be applicable, that is 1 less than E less than phi of n, means 1 less than 7 less than 160. That is true. So E should not be factor of our value of phi of n. So E is 7. It is not the factor of 160, and GCD of E and phi of n is equal to 1. That is GCD of 7 and 160 is equal to 1. So these three rules are applicable here. Then we will go for finding of our private key. So the formula for finding the value of our private key, that is T, is equal to D into E mod of phi of n is equal to 1. So the value of D is not known. E is equal to 7. Then mod of 160 is equal to 1. So for finding the value of this D, we will use extended Euclidean algorithm. So first of all, we need to make a column for this extended Euclidean algorithm. So we require these 7 columns and I'm putting the values here. Like first of all, quotient is there, then value of our A, value of our B, then remainder, value of T1, T2 and value of T. So value of A is nothing but your value of phi of n. So your phi of n is equal to 160. So I am putting here value 160. Then value of B is value of your private key or value of your public key. So here value of public key is given, that is 7. So I am putting here value of B is equal to 7. Now value of T1 and T2 will be 0 and 1 respectively. And now we will start to finding our value of quotient and remainder. So 160 divided by 7, we will get the value 22 as a quotient and 6 as remainder. So value of T is equal to T1 minus T2 into quotient. So after putting the values into formula, we will get 0 minus 1 into 22, that is minus 22. Now 7 will be shifted here. 6 will be shifted in the column of B, 1 will be shifted in the column of T1, and minus 22 will be shifted in the column of T2. Again, we have to find 7 divided by 6. That is 6 ones are 6, and we will get the remainder 1. So for this one, T1 and T2, we will find 1 minus 22 into quotient, that is 1. And we will get the value, that is 23. Again, we have to shift the value 6 here and 1 here, then minus 22, and here it is 23. Now, we can calculate 6 divided by 1, that is 6, and we will get the remainder 0. Then we are calculating here value of t is equal to minus 22 into 23 minus 22 minus 23 into quotient, that is 6. And we will get here the value, that is minus 160. So I am putting here minus 160, and then again we are doing shifting operation, that is 1. Here it is 0, here it is 23, and here it is minus 160. We got here 0 as a reminder. So in the column of B, we will get the value 0, then we will stop this procedure, and we are not finding the quotient and remainder again, as well as value of t again. So here you can observe that in the column, which value you got in the column of T1, that is 23. In the column of T1, you got the value, that is 23. Okay. So what is the rule for finding the value of your private key? Your private key is the value of our D. But you have to check that if T1 is positive, then value of D is equal to T1. If T1 is negative, then what you are doing? D is equal to T1 plus T2. But here in this case, value of our T1 is equal to positive, that is 23. So my value of my private key, that is D, is equal to 23. So here we got the value of our private key. So till that, what we have solved? We have the value of our E, that is 7, value of our N, that is 187. We got the value of our phi of N. So phi of N we have calculated, that is 160, and we have calculated the value of our private key, that is 23. Now what is the next step? We have to calculate the value of our ciphertext. Based on the value of M, 10 is given, that is plain text is given. So now you have to perform the process of encryption. So in the encryption, you are using the formula, that is P is equal to C is equal to P raised to E mod of N. So we are taking this plain text as a message raised to E mod of N. So the value of our M is given, that is 10. So we are putting here value 10. The value of our public key is given, that is 7. So I am putting here value 7 mod of N. So value of our N is given in the example in the key pair 7187. So E, that is value 7, and value of our N given, that is 187. So based on that, we have to find the values. So first of all, we will find 10 raised to 1 mod of 187. So 10 raised to 1 mod of 187 is equal to 10. Now we will find value of 10 raised to 2 mod of 187 is equal to 10 raised to 1 into 10 raised to 1 mod of 187. And we will get the value, that is 10 into 10 mod of 187. So 100 into 100 mod of 187, we will get the value. That is, we can also write it as 100 as answer, or else 100 minus 187 is equal to, you can consider here as minus 87. So you can put both the answers here. Now we will find 10 raised to 4 mod of 187 is nothing but 10 raised to 2 into 10 raised to 2 mod of 187. So 10 raised to 2 is nothing but 100, or else also you can put here minus 87 into minus 87 mod of 187. And the value for this question is, answer is 89, or you can put 89 minus 187, that is minus 98. Now we will find the answer for our 10 raised to 7 mod of 187 is equal to 10 raised to 4 into 10 raised to 2 into 10 raised to 1 mod of 187. So you have to put the values of your 10 raised to 4, that is 89, then 10 raised to 2, that is 100, and 10 raised to 1, that is 10 mod of 187. So you will get the value 89000 mod of 187 is equal to, when you calculate by using calculator, you will get the value 175. That is the answer for your ciphertext. So in this way, we have find our value of our ciphertext. Whenever you are finding the value of your private key, that is D is equal to 23, that time you have to check this formula. That is D into E mod of phi of n is equal to 1. So which value you got in the value of D? That is 23. So 23 into 7 mod of 160. So it should be equal to 1. If it is equal to 1, then your value of your private key is correct. So in the given example, we have elaborated the RSA example steps, RSA algorithm steps. Then we have calculated the value of our phi of n, value of our public key is given. Based on that, we have find the value of our private key, and based on the plain text is given, we have calculated our ciphertext. That is, the encryption is performed. So this question is asked in the Mumbai University question paper 2 times, that is on May 2022 and May 2023.